Hey guys, it's been a long time since I've made a video, so I figured I'd go ahead and create a short one this morning and we do a little programming and assembly language. Hope all of you are well. I've been very busy with life and with work, and doesn't mean that I've forgotten about the channel and that I'm not interested in doing more videos on Atari and also some Commodore 64 stuff. I know some of the Atari guys don't like to hear about that, but I do like the Commodore 64, and I do play with the VIC-20 occasionally. I had to do some repairs on mine recently on the power supply, but hopefully we'll be getting back into we'll be getting into doing some videos on the VIC-20. So anyway, I saw a video a couple months ago made by Thom Cherryhomes where he did a tutorial on how to create a status bar using display lists in BASIC, Atari Basic. I thought it was a really good video. It was very interesting how he put together the display list for that. So what I thought I would do is take his code that he did in BASIC and convert it over to assembly language. Since the overwhelming majority of requests that I get on this channel is to show more tutorials in assembly language, I thought we'd do that. So without fully explaining what he did in BASIC, because he did a pretty good job of it, I'm just going to talk about a few things that that he did in the code, and then what I thought I would do a little bit differently in the assembly language code to make it work. But it's very useful code. You'll probably use it if you're writing any programs in Atari that you need a status bar on the top, or maybe a high score for a game at the top. So it takes advantage of the display list programming, which I've done, I think, a couple videos on that, on how to do that on the Atari. But we can never talk enough about programming on the Atari until, sometimes it takes several times to get the concept down. I know when I was learning display lists, back in the day, it took me a while to get my head wrapped around how they worked. And but anyway, it's good to be back. And I'm going to be doing some more videos here shortly. And so anyway, let's take a look at how we can modify it, his code into assembly language. So here we go. Also, I did want to mention that today we're going to be using the Side 2 cartridge for our development purposes. And I've got this cartridge set up with the Mac 65 assembler editor / debugger. So if you guys want to learn about the Side 2 cartridge, I've got a video on that. I'll throw a link in the description on where you can read about this. Also, I received this Ace 80 XL cartridge by Gavin over at the Vintage Computer Center. And I promised to do a review on this cartridge. I'm sorry that I haven't done it yet. I've been so busy, but I am going to be taking a look at this cartridge and what we can do with it. I know Thom Cherryhomes did some work with the FujiNet where he was actually able to get some software working with it, but I haven't had really the time to play with it, so I don't know how this is going to fit into my work on the Atari, but I like the fact that it's in a cartridge. I just don't know how well it's going to play with some of the software that I use to do my development, but we'll take a look at that as well. So keep your eyes peeled for that video as well. And as always, stick around. It's going to be good. Don't go anywhere. All right, let's go ahead and boot the Atari into our assembler editor environment, starting with the Side 2 cartridge, which will then ultimately roll us into Sparta-DOS. And at the Sparta-DOS prompt, we can type car because I have the assembler editor set up as the cartridge ROM for my Side 2. And here we are, Mac 65. So you guys, if you've watched the video that Thom made where he typed in the BASIC program that gave you a status bar on the top of the screen, we're going to do it in assembly language. So I've got some notes off to the side here that you can't see that I've already kind of written down. So we're just going to wing this and hope that we can get it working before the end of the video without too many issues. So I'm going to go ahead and type in the command to save this program like I always do as a comment in the first line of my assembler. And the reason I do that is If I want to save this program over and over again, I don't remember, and I don't have to remember what the name of the program is. So I can do, let's just do right now, X. So here's the start of our program. If I just come here and do this, that command actually lists it to the disk. So let's go ahead and make another comment here. We're going to say simple status bar, top of screen. Okay. Now, we have to give this program somewhere in memory to live. I'm going to use 3000. And by the way, guys, I think we're going to do a video on the memory map of the Atari 8-bits because I got a lot of questions in the past about, you know, hey, where should I put my program in memory? I've got a Atari 800, or I've got a 800 XL, or I've got a Atari 130 XE. Well, you need to know how the Atari memory is laid out before we answer that question. So promise you guys I'll make a video where we talk about the memory map of the computer. It's kind of important to know, especially when you're writing programs in assembly and you're putting code directly into memory. So we'll get to that as well. So we're going to start our program at 3000. Let's see if this assembles right away. Okay, so we've got no errors. It's kind of cool. All right, so let's continue. We need to tell the Mac65 assembler editor to actually create object code in memory, and we do that with the macro option called obj. I did that wrong. This needs to be just one space. Oh, did I do something wrong here? Oh, I'm spelling it wrong. It's kind of late while I'm creating this video. And I did it again. OPT, you idiot. There we go. If you guys don't know what that means, if I don't put this line in my code for this assembler editor cartridge right now, and I assemble the program, it actually will not assemble in memory. It just runs through the assembly process of detecting any errors, but it doesn't actually create any code in memory. So you have to have that directive there for it to actually put this code into memory, so you can execute it ultimately. All right, so back in the basic version of the program, we had a string variable called dlist string, which is actually a string of bytes that contains the instructions to create the display list. So the way we're going to do that here is we're going to create a label called dlist, and that is going to be of a byte structure. In other words, a string of bytes. And we're going to go ahead and start off with the way that it was done in the basic program, which is using the ASCII characters. So there was two lowercase p's and uppercase b. And then we had the two heart symbols, which are zeros, by the way. Then we had this bar, which is a control B on the Atari keyboard. Those of you guys that want to type this program in using Altera or one of the other emulators, you know, it's kind of hard to find these characters, you know, mapped to whatever PC or Mac keyboard you're using. So I'm going to show you an alternate way to put these bytes here without using these funky characters. We're going to actually use numbers. We'll do that after. So the next character is going to be that little spade character. And then we've got another capital B, another couple hearts, which is zeros. And then we've got 23 of these bars again. So that's going to be on the Atari keyboard, control B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We got a capital A, two more hearts, and then close quote. So that's the display list right there for this sample program. And I do encourage you guys, if you haven't seen Thom's video, go watch it. It's gonna, because I'm really not gonna explain too much how this program works. I'm just showing you how to write it in assembly language, translate it from basic to assembly. All right, so the next thing we need is a byte stream, or as it was in basic, there was a string that stored the text that was going to be displayed in the status bar at the top of the screen. So we're going to do another byte setup here, and we are going to do what he did in his video. So we're going to use the inverse ASCII lowercase testing, and the way you get that on the Atari keyboard is you hit caps to get lowercase, and you hit the inverse key on the lower right hand part of the keyboard to give you inverse characters. And then we got to space it out to fill up the rest of the status bar with zeros or nothing, spaces if you will. So that's the hearts, inverse heart. So we're going to do 73 of those. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, close quote. Boom. So now we got that. Okay. So now the next thing we need to do is, let's put another comment in here just so we can talk about what's going on next. I like to make my comments read clearly. So I usually do inverse ASCII lowercase. So now we're going to point top 2 lines and display to status bar string. Line 130. Here's where we actually get to some code. So we're going to load the accumulator with the low byte of the status bar string. What this little trick here does for the assembler editor when you do this pound less than sign is what it's loading the accumulator with. In memory, this status bar here, or this byte stream here that represents the text in the status bar, is loaded into memory, you know, probably somewhere right around 30 or something like that. If you were looking at memory, you could see it once this program executes. So what we're doing is we're loading into the accumulator the low byte of where that status bar in memory. So if the memory address was 3030, then the accumulator would hold hex 30 right now. So that's a little trick in order to extract low byte out of a memory location, or an address, if you will. So we're going to store that into the display list beginning plus 3 bytes. So basically, if you look up here on the display list, we have 112, 112, which is 16, I think it's 18 blank scan lines. Yeah. And then right here, these 2 bytes right here, so 0, 1, 2, 3, these are zeros, okay? And we did that on purpose because we knew we were going to be filling them in later on. So that's what this is doing down here. This is basically replacing those 2 bytes. The first one is going to be the low byte of the display list, string, if you will. And then we're going to do it again for the high byte. So the way you grab the high byte is with the greater than sign, stat, and then we're going to store that into display list memory plus 4. So we're basically replacing these 2 bytes right here with the beginning in memory of where this text is going to start getting displayed from. All right? Okay. So we got that down. So next, we need to tell the computer that the display list needs to start displaying the rest of the area of the display memory, you know, where it would normally grab the bytes from, which is in hex 5859 or in 8889 in decimal. Refer to your mapping the Atari if you want to know about these addresses, by the way. So let's go ahead and use our little commenting style here. The rest of the display will use, let's go 180. Normal screen memory. I don't know. Does that make sense? I know what it means. I hope you know what it means. And the way we do that is we load the accumulator with what's in 58. And we're going to basically store that into dlist plus 8. So we're basically telling the computer, display what you normally display from here on out after this status bar. And we're filling in these 2 bytes here from where they come from in memory, which is 58 and 59. All right. Actually, I goofed this. No, I didn't. That's right. So now let's load what's in 59. And let's store that into dlist plus 9. Cool. Why don't we save what we have? Here's how we do that. That's why I do this in the beginning, so I can remember what it needs to be saved as. Boom. Okay. Does this assemble without any errors? So far, yes, 0 errors. Cool. All right. So what else do we need to do? Oh, so now we need to tell the computer, oh, we've got to point the end of the display list back to the front. So up here, we filled in these 2 blanks with the beginning of memory of where the status bar is located. We filled in these 2 zeros where we want the rest of the screen display to start displaying from. And now we need to fill in these last 2 bytes of the display list, which is going to basically point right back up to here, the beginning of our display list. So these 2 bytes have to point in memory where these 2 bytes are. So how do we do that? Well, we start with a new line number. And we load into the accumulator what is the low byte of the display list itself. And we need to store that into the display list itself at the end, which 34 bytes towards the end. So we're basically pointing the front of the display list to the end of the display list. It's like a loop, circular return. And let's grab the high byte, oops, of the display list. All right, and let's store that into dlist plus 35. All right, that's cool. So now what do we need to do? We need another comment. More comments in our life. Tell the Atari to use our new dlist. How's that? Works for me. Okay. So how do we do that? Let's see. we need to, in the Atari, you've got locations 230 and 231 in hex. Those two locations tell the computer where the current display list is located. So we just created a new display list, so we need to tell the computer where to get it. The way we're going to do that is simple. We're going to say load the accumulator with the low byte of the display list and store that into 230. And let's also grab the high byte of the display list. And let's store that into 231. Okay, so now the computer has our display list. It knows what's in the display list and it knows where to find the display list. So what I'm going to do now is assemble it. Actually, let's save it real quick. Now, keep note while we assemble this here. Let me just pause this while we assemble. You can see the top part is all data. It's just bytes. The actual code that we're going to start executing this is going to start at, if you look right there, 3074. See that 3074 all the way in the left-hand column? That's our first load accumulator. That's where this thing actually starts. Just keep that in mind. All right, so there we go. We've assembled with no errors. Let's go into the debugger. If you guys don't know what this is, go look through my videos. You'll find out what this is and how to use it. This is basically the debugger that was written by James Dunyan that was ultimately used for this cartridge. So let's basically jump with the G command to location 3074 and let's see what happens. And what did we get? Oh, we got some nastiness going on, which tells me that we've got a bug in this program. Well, that's cool. We're back. Now, some of you may have been savvy enough to actually see where I goofed this, but I'm not going to waste a bunch of time and just wait, to figure out what happened. I can see it right here. So basically, if you look in the last line right here, I stored the high byte of the display list into decimal memory location 230 instead of hex. Actually, I should put a 0 here to make it properly. 231. So what I ended up doing was I screwed up the memory location, the high byte memory location of where the Atari thinks the display is coming from. That's why we were getting that weird effect. So easy enough to fix that. Let's go ahead and reassemble. Let's go into the debugger. Let's jump right to 374 where the program starts and whammo. So it didn't actually do anything on this screen because the program basically ended, but the display list is actually modified for the regular screen. This debugger uses its own display list, so once we quit this debugger, we get back to the main screen here and you can actually see that that status bar is up there just as it was in Tom's demonstration. And you can see here, we're listing our code. That status bar is not moving at the top. It's fixed. It's good to go. And everything else that he describes in his video holds true here. You can modify that string directly in memory and it will basically change instantly up there at the top. So anyway, just wanted you guys to see a different view of this program. It's a cool little program. And this snippet of code here, I'm sure it could be used in any of your assembly language programs that you're writing or playing with. And as a matter of fact, we started a game a while back, in one of my videos on how to move a spaceship across the screen. We're going to get back to that code. We're going to finish that game eventually. And we'll probably use this code here to put the high scores at the top of the screen. Why not? It's good code and it works. So anyway, thanks for watching, guys. Got some stuff coming up, like I said, and stay tuned for more videos. And make sure you like and subscribe so we can get everybody involved in programming on the Atari. See ya.